Hey, what's going on, guys? Today I'll be going over the balanced parentheses problem. This is a very popular coding interview problem, and one of my friends actually got this problem on his Amazon interview. So what it basically entails is, given a string, you're supposed to find if that string has valid parentheses or not. And essentially, this is not limited to just parentheses. Also includes curly braces and brackets as well. So this algorithm is actually used in compilers to see if your syntax is valid or not. And for this problem, there is no obvious brute force solution. The solution you want to be using is a stack. So essentially, the stack will keep track of all of the opening parentheses. So you want to loop through the string and add all of the opening parentheses onto the stack. And then once you get to a closing parentheses, you want to pop from the stack. And what you're popping is the last element added, so that last element added to the stack should be its equivalent opening parentheses. So what you're adding to the stack is just the opening parentheses, and then once you get to a closing parentheses, you want to pop that equivalent opening parentheses from the stack. So let's go through it here. So we're going to loop through this string, and the first thing we see is a brace. So we're going to add that to our stack. We're going to push that element onto the stack. And then we have that here. And then now we reach a bracket. So we want to push that onto the stack. And then we reach a parentheses. So we want to push that onto the stack. And then now we go through, and all of these regular string elements we just want to ignore. We don't really care about them because they don't really matter. And then now we get to this closing parentheses. So now that we have this closing parentheses, we want to actually pop the top element. And if this top element is its equivalent opening parentheses, then that means the parentheses are still balanced. We pop that, and then we get to this brace here, and then we pop that, and then we get to this last bracket here, and then we pop that. And what we're left with is an empty stack. So if the stack is empty, that means the string does have valid and balanced parentheses. So let's go through the code. And what you'll notice here is we have a hash table called bracket pair, and this hash table keeps track of the opening parentheses and its equivalent closing parentheses. And we can use that to look up the complementary parentheses. So let's start off by looping through, and we start at this first element here, and we see that it's a curly brace, and we check to see if that curly brace is in the hash table, and it is, in which case you push it onto the stack. So we have that here, and then we go on to our next loop, and then we have an S, and that S is not in the bracket pair, so we move on. And then we have this element here, which is a bracket, and then we add that, we loop through, add the opening parentheses, and then we ignore all of these just regular string elements, regular characters, and now we get to this closing parentheses. So in the event that we get to this closing parentheses and we get to this line here, else if the stack is not empty, so this is shorthand notation for Python to check to see if the stack is not empty, and the current element complementary value is in the bracket pair. And if the current element is equal to the value stored in the hash table, so in this case the current element is the closing parentheses, and then we look up this bracket pairs whatever on the top of the stack, so we have an open parentheses, and then we look up the complement value, and then that's a closing parentheses, and this value is equal to our current elements, and that means we pop it. And in the event that it's not, that means you can return false. And when we return false, we know that the string doesn't have valid parentheses. So let's go ahead and pop the top of the stack, and then we eventually get to this closing bracket, and then we would pop this element off the stack, and then we would get to this closing curly bracket, and we pop this element. And then now we're left with an empty stack, and we return true if the stack is empty, which is essentially this line here. And that's pretty much it, guys. This solution has an O of n runtime as well as space complexity. And thanks for watching, and I'll see you in the next one.